Okay, finally, what happens if your kidneys don't work properly? So kidney failure. Basically, there's two options with this. If your kidneys conk out and will not work at all, and you've got two, and you can operate fine just with one. So this is quite serious when both your kidneys don't work. The long-term answer to kidney failure is a kidney transplant. So what they would do is they would basically find somebody who has a tissue match the same as yours. So making sure that their kidneys, their tissues, their blood, everything is the same group as yours and will match yours very carefully. The reason they have to do this is because there is a possible chance that your body will that your body will reject the kidney that's been transplanted into it. So you need to get it to match as closely as possible. And so what they would do is they take the one healthy kidney from the person who's got the same tissue match as you and transplant it into your body. Obviously, that does carry risk with surgery. It's not straightforward just to transplant a kidney. Something they do a lot of these days, but actually potentially can be life-threatening. It's a good thing though, because it gives you a long-term solution to the kidney issues. So in theory, your new transplanted kidney will last you a long time. So downsides, you've got to have a tissue match. You might reject it, risks of surgery, but on the plus side, it is a long-term solution to kidney failure. Okay. The alternative, while you're waiting, or if you don't want surgery, is to have kidney dialysis. And basically what that means is you take, a little bit down here, what you do is you have your, right, here goes some drawing, you have your person, that would be an arm, just so you know. You take the blood out of a person, so just stick a needle in it and let the blood pump out like if you were having a blood test. And then you run it through a machine. So there's these really funky machines called dialysis machines, and they basically work like a kidney. So inside they've got a partially permeable membrane, so the dotted line basically is a partially permeable membrane, so we know what PPM stands for, partially permeable membrane. And inside of the fluid, in here, you have got the ideal iron and water concentration of the blood. Okay, so for example, the solution in here contains exactly the amount of water you'd want in someone's blood and exactly the amount of ions you would want in someone's blood, and it's basically contained within this machine, separated from the actual blood by a partially permeable membrane. So your blood goes in here, and if you think about it, remember our colour coding from before, our urea, there's a high concentration in the blood, there's none in this solution here because you wouldn't want urea in your blood, it's a waste product. So all of the urea goes through the partially permeable membrane and into the solution. Okay. All the other substances, so the glucose, you would have the amount of glucose in the solution that you would want in your blood, which means that you'd get some moving in both directions, but ultimately you will end up with your blood containing the concentration that you would want it to have, because some might move here, some might move back. If the concentrations are equal, then not much net movement is going to happen, is it? And that also applies to water. So there's the concentration of water in this solution that you would want in your blood, which means that no water will leave or gain overall, so there's no net movement of water. And then again, with the ions, if you've got a sodium ion concentration here in the solution that is the same as you would want in your blood, what happens is you get no net movement of ions. Some will move this way, some will move back, but ultimately the blood will contain the glucose, water and ions that it needs. Any excess will have come into the solution here, and all the urea will have come into the solution here. Though that solution, and I haven't really drawn it on here, but that solution is constantly being pumped out and pumped back in again, okay? And then the blood flows out the other end, and then the blood goes back into the body again. Okay, so you take somebody's blood out, run it through the machine, it acts like a kidney, back into their body again. Downside of this, so there's got to be pros and cons to everything. A downside of this is it's damned expensive. So kidney dialysis machines are really expensive. Things have changed a bit now, but it's also very restrictive. So I had a friend who, a very long story that I'm not going to tell you now how I met her, but anyway, she had to have kidney dialysis and she had to go 3 days a week to the hospital and be there all day plugged into the machine. So it's very restrictive. It means you are literally having to have your kidney under dialysis for a lot of the time. There are now new machines, I think, that people can have overnight and things like that, so it's getting better in that front. The plus side to all of this, though, is compared with surgery, it's relatively safe. Just have your blood taken out and put back in, and it's not as straightforward as that, but it is safer than surgery.